Okay, again, hi to all the students. I hope you're fine and good afternoon to all of you. We start the discussion and teaching and read a little more for other students. Do you have any questions from previous sessions? No? Okay. Okay, and today is session 15. Okay. In the name of God, we start the session 15. About 2 or 3 or 4 sessions, we have started the studying of neural network, and we have reviewed Rashid book. I don't know you study this book, this reference or not, but it is too interesting book, too simple. You study, and then said that, oh, you studied about, for example, 30 pages or 20 pages. Very simple and very simple and clear sentences. He explains the concept of the neural network. At first, I only review what previous sessions and then follow it, because maybe some of you don't have reviewed the videos. As you see here, the content after the introduction at first in part 1, he explains about some concept and nodes, neurons, backpropagation arrows, waiting update, and like this. Very simple way explains. And then after that, using the previous part, he explains the commands in Python and comment the neural network in Python. We also follow this content, and then after that, if we have time, we will review the deep learning. I think we have time. We will have time to review the different types of structures for deep learning, deep neural networks. Okay. The first question is that, and the first thing is that he said that, okay, in human, when we see question, we think and then answer. Computer also, we feed input data to the computer, and then after that the computer do some processing, and then we have output. About the goal in our in these topics in this book is the classifier again, and then he explained about the very simple example. For example, he considered how we transform the kilometers to miles. At first, he predicted it, he guessed it like a linear relationship between this input and outputs, and try to find the best linear relationship between input and output. Then by calculating the error, he tries to find this linear relationship. Okay. And then after that, he said that if we have two groups of data, we said about the classification. But in this book, step by step, he explained. For example, he said that, okay, this blue line is not good because this red circle is in the class 1. Then this blue line of again is not good because if we consider two groups, both of them are in one group. This is good, but how we can find it? Okay, it said that, okay, if we have, I explained in details in the videos, but said that, okay, if we have some example using those examples and samples, we can guess this correct linear classification, and then again, but first by guessing and initializing a slope to this line, and consider the error between the desired line and this calculated value, then updated the slope of this blue line. I explain how to find this. I only want to review it. Then after calculating the error and find the final refinement, final line, then we can moderate this classification, because if you attention, this line is too near to red object. Okay, then he introduced a moderation way, a method which is so simple. How we can moderate this line, and then after that we achieve this. The equation, the mathematical relationship is in the book, and also I explained in the previous videos. Okay, and then after that, okay, sometimes we have, for example, if this data is related to logical, and this line can separate the green and the red circles. If we have all, then we can one line. But if we have XO, one line is not necessary. We need two lines. And sometimes our data, we cannot separate our data using linear classification. We need non-linear classification. Then neural networks is a good candidate for our goal. Then we introduce a neuron as a cell, and then explain how we can model the neuron, how we can model the operation of the neuron, and then introduce the activation function, and said that how the neuron, how the node works. And in our body, in another nervous system, we explain how the signals transform or pass through the neurons. Then using this concept, we introduce these layers, these neural networks, and said that okay, we have input layer, output layers, hidden layers, and then said that the connection between nodes is applicable using some weights. Okay, and then said that if we have neural network with 2 layers, in each layer we have 2 nodes, how these neural networks works. And said that okay, for example, the input for node 1 is 1. Node 1 multiplied by 0.9 and then reach to the node 1 of layer 2. And this happens for other connections. Okay, I explained in fast, and then after that for new concepts I will explain more. Okay, in the source said that neural networks is deep learning. No, neural networks is not deep learning. Neural networks is a type of classification. Okay, is a method for classification, and of course neural networks have other application. Deep learning is the next step of the neural networks. We will explain. Okay, I hope to see and watch the videos. Then finally, using this equation, I is related to input, W is related to weighting, and then we can calculate the X, the output of each node. Okay, and then after that we explain we have activation function, pass through the activation function. For example, if you have sigmoid, we only must use this equation and calculate the output of each node. I think we explained it again. Okay, no, this is our new topic. Okay, till we explained about 16 pages in our video, and now we want, after fast reviewing, we want to follow it. Okay, now consider we have a 3-layer matrix. As I said before, the first layer we called it input layer, and the last layer we called it output layer. This neural network contains 3 layers. In each layer we have 3 nodes. 1, 2, 3, 1, 2, 3. And other layers between input and outputs we called hidden layers. In this diagram, we have only one hidden layer, but maybe we have 2, 3, 5 hidden layers. Okay, and as you see again, there are some matrix, some weights, some connections between nodes. For example, node 1 from first layer and node 1 from the hidden layer. The weight is W11. The weight is W11. The connection between node 1 and node 2, the weight is W12. Okay, you see, and this happens for other nodes. As we said before, because the computer works on matrix, then we can rewrite these weights, this connection, in the form of the matrix. Okay, in the form of matrix. And for this neural networks, we have a matrix, we have a W matrix between the first layer and the second layer. Input layer between this W is the connection between input layer and hidden layer. And we have another weighting matrix between hidden layer and output layer. So the book called it W with the end is of input, hidden, okay, hidden, I don't continue, and this W called it W of hidden, okay, hidden output. Okay, then we have 3 layers. We have 2 weighting matrix. It is clear. And this is the vector of input. We called it I. Okay, and after we calculate the outputs, we have O. O means outputs. Okay. The input layer, the nodes in the input layer don't have activation functions, but other layers have it. Okay. Okay. Then here you see that W from input hidden layer. The first array, the first amount is 0.9. It means that we called it W11. It means that the connection between the first node of first layer and the first node of hidden layer. It is the connection between the second node of first layer and the second node of the second layer. We call it W22, and this is related to 3. Okay, and for example, this is the weighting of the third node of the first layer and the first node of the hidden layer. Okay, in this book, this weighting matrix was introduced in this way. Okay. No questions? Okay. And the weighting matrix between hidden and outputs. Again, this is W11, this is W33, 0.9. Again, come back to the diagram. The connection between third node of the hidden and the third node of the output layer. Okay? We can interpret the weighting matrix in this way. And I is the input matrix, input vector 0.9, 0.1, 0.8. Okay. Then, according to the previous discussion and study, we said that X hidden is equal to W input hidden multiplied by I. Then X hidden, W of input hidden, the connection between the input layer and hidden layer multiplied by input. After the calculation, the output is this. X hidden is equal to this. You know that how it multiplied this row multiplied by this vector, and then equal to this. Again, this row multiplied by this, and the result is this. And this multiplied again by this vector, the result is this. Okay? Okay. And in this diagram, for example, the first is 1.16. Okay? Then the X for the hidden layer is this. The X of hidden layer after those calculations is this and this. But these nodes have activation functions. Then the X hidden, it means this. Pass through the activation function, and here we consider that this activation function is sigmoid, and the sigmoid is this. The equation of sigmoid is this. Yet divided by exponential minus x. Then this x, for example, the output of this is called O hidden. O, and this let me to zoom on it. The output of hidden layer can be calculated after passing the sigmoid activation function. Okay. Then after that, the output of hidden layer is this. It's calculate by this. X divided by 1 plus exponential s. Calculated. We do this for the second and third. Okay. Then the output of the hidden calculated in this way. And then in this diagram, you see the output hidden. Then these outputs is the input for the third layer. The output of the second layer used for the as the input for the third layer. Again, we have the W matrix. We have the W matrix. We called it W hidden output. The weighting between hidden layer and output multiplied by O hidden. O hidden, you know, we explain. And then we calculate X output. Okay. And then again, this is the X output. This X output must pass through the activation function. Again, we know the activation function is sigmoid. And then again, using the same equation, I explain, we pass this from the sigmoid, and then the output is this. Okay. Then in this diagram, you can see the outputs. No questions? I hope all things would be clear for you. It is too simple, but only takes time to calculate. Okay? And now the question. We considered one time two-layer neural networks. After that, we considered three-layer neural network, and we calculate the output. Okay. Now the question is that, okay, we calculate the output, but how we can update the weighting values? Because as you know, we said that in machine learning, at first we train the neural network and we update it in different steps, and then after that we feed the test data and then evaluate the neural networks. We learned about the calculating the outputs of the neural network, but we don't know how we can update the weights. Okay. To reach this answer, consider that we have two layers. The first layer contains two nodes, and the second layer contains only one node. Okay, this diagram is used only for understanding and getting the concept of the updating the weights. Okay, and then after that we use more sophisticated, more complex neural networks. As you see in the previous sessions, in the previous videos, we said that okay, we have for example, for linear classification, we said that okay, we calculate this line, the slope of this line, but we know that the desired slope is this blue one. We calculate the errors, and then step by step we try to decrease the error. Okay, we tried to decrease this pink error. We can consider, again I said that we can consider this linear classification like only one node. Okay, but now we have two nodes, and we want again using the arrows. Okay, we said that if we know the target, for example here, target, or if we have some examples, if we have the correct value of the outputs, then we can know the output errors. We have inputs, we have some weights, we calculate the outputs. On the other hand, we have the correct output. Then we can calculate the error. But how we can use this output error to update the weights, to refine the weighting? How we can use it? One strategy, one method is that we divided this output equal to the nodes. For example, if we call the error capital E, and if we have two nodes, then half of the error, we can say that the half of the error is related to the first node, and the half of the error is related to the second node. This is one strategy. Another strategy is that okay, we calculate the error. Okay, but as we see in this diagram, we see that the weighting of the first node is 3, and the weighting of the second node is 1. It means that the contribution of the first node is larger than the contribution of the second node, because the weights are different. The weights is not as the same value. One of them is 3 and one of them is 1. Then the effect and contribution of the first node is more than of the effect and contribution of the second node. Then we can split, we can divide this error according to the weightings. Okay, we can split this error according to the weightings. This is another strategy, and it seems that the second strategy is better. And in this diagram you can see these two different strategies. If we consider the same contribution for the nodes, then we split the error in the same value, and in the other hands, we can split the error according to the weights. For example, here, we can split the output error for the first node 3/4, and for the second node we can set that okay, this contribution of this node is less, then the effects of this node is 1 divided 4, or in other hands is that 0.25 of the effect of this node is around this fraction. Okay, and we split the error according to these weightings. Okay, any questions? Any questions? Okay. And another thing is that if you attention, the summation of this fraction is equal to 1. And how we can calculate this fraction? I will explain. In the next, I will explain. Okay. Now consider that you have with 2 nodes in each layer. Okay. Finally, you have 2 outputs. Then you can calculate 2 errors, E1 and E2. Okay. How many nodes affects a node 1 in the layer 2? 2 nodes. The first node of layers and the second nodes of the first layer. Then E1 is split according to W11 and W21. No, here, okay, Intesar said that error calculated in this way by calculating the differences or the fraction, by calculating the differences, not the fraction. Okay? Okay, Intesar? If I pronounce your name correctly. For example, E1, and now not between output and input, between calculated value and target. Target minus the calculated output. Okay, T here is the target and O here is the target. And then according to the weightings, we split the inputs to the previous nodes. Okay, no questions? Okay, and again for E2, we split E2 to weights, because the first and second nodes in the first layer, both of them affect on the second node of the layer 2. Okay, and as you see, Intesa said that okay, E1 is equal to the target 1. Target 1 is our desired value minus output 1. Output 1 is the calculated output, as I explained you in before pages. And as you see how we split the error, we said that okay, for example, we said that W11 divided by the summation of the weighting W11 and W21. Again, here consider this, how we can split E1 W11 divided by W11 plus W21. Two ways that affect on the first node. And this is W21 is divided again W11 plus W21. Okay, and for the both of them multiplied by E1. And for the second, for example, for this line, we said that W12 is divided by W12 plus W22. Why we use this weighting? Because these weightings affects on the second node, and then this multiplied by E2. And for the second updating, we said that okay, W22 is divided by W12 plus W22 multiplied by E2. Okay, any questions? Then till now, if you review what we learned, at first we introduced neuron, then we said that each neuron can have activation functions, we consider layers, we calculated the outputs. Okay, but we don't know our output is good or not. Okay, then we consider the targets, we calculate the errors. Okay, and now we want to update the neurons, we want to update the weightings of neurons to achieve the best outputs. The best outputs means that the errors is less. Okay, and in this way we try to update the weightings. Okay. And now in this neural network, it is too simple. We have input and output layer. We have target. Now, if we have 3 layers, okay, we use the arrow and we backed this arrow to the previous layer, and we call this strategy back propagation. We propagate the errors to the previous layers. Then because of this, we said that backpropagation. Okay. The backpropagation means this. But if we have three layers, okay, for the output layer, we have targets, we calculate the outputs, and then we have targets. We can calculate the differences between targets and outputs, and we can achieve the errors. And then we backpropagate this error to the previous layers. But from the hidden layer, how we can backpropagate to the first layer? How? Because we don't have any target here. We don't have any targets for a hidden layer. Then how we can backpropagate the errors to the previous ones? Now we want to answer these questions. As you see here, we don't have the error of hidden layer. Okay. How we can calculate the error of hidden? As you see in the previous pages, we said that we split this error according to W12 and W21. Okay, and we split this. And we split this output according to W12 and to W22. Using some fractions, some mathematical equation, we split this error and we backpropagate this error to the previous layer. Okay? Then now consider the node 1 of the hidden layer. We have two errors according to two weighting connections. Okay, from W11 from this pink and W12 according to this blue one. Then the error here is the summation of this and this. The errors, the summation of errors relating to this and this. And for the second node, again we have these errors, the effect of this arrow and this arrow. One of them is for pink and another one is for blue. Then we can sum these arrows. And in this way, we can calculate the error of the hidden layers. Then after that, we backpropagate the error of hidden layer to the input layer, and we update the weights. Okay? And here you can also say that, okay, the error of hidden layer for the first node is the sum of split errors on links W11 and W12, as I said you before. Okay, Then in this way, for example, using this fraction, you can calculate the error 1 and error 2 for the hidden layer. And then you can continue this back propagation to the first layer. For example, you use this. You can achieve the errors for the input layers. Okay. Now, again said that okay, we can collect them in this matrix form. All of the discussion, all of the explanation that I said, we can gather all of them in this matrix equation and say that, for example, okay, error of hidden is the, for example, for the first node, it means that if we open this, error of hidden 1 and error of hidden 2. Okay, the error of the first node and the error of the second node. Then it means that this row multiplied by this column, and error 2 is equal to multiplied by the second row by this vector, the previous equation that I said. Okay, and then totally we can set the fraction, we can set it, okay, W11, W12, and blah blah blah. Okay, and as we know, the transpose of a matrix is this. You know, the location of row and columns change. This row comes to these columns. We know that the second row, the second column, the third row, third column. We called it the transpose of the matrix. Okay, and if you consider here, error hidden is equal to this matrix and this weighting matrix multiplied by error. Okay, and using the transpose, we can set that the error hidden is equal to W transpose of hidden output multiplied by error output. We can conclude it with. Okay. And the next question. Okay, Naima said that. Yes, Naima. The discussion in this book is only about the neural network, because we want to review the neural network, and then after that we want to study the deep learning. Yes, Antazar, we review all the book, all pages of this book. It is too simple. If you attention, we reviewed 18 functions, 18 pages. You are worried. Your questions is that you are worried, and I think that you can't understand the details. One reason for these questions, and maybe you don't have watched the video relating to these books, and I think only one reason. And another thing is that you yourself don't have studied this book. And then maybe you cannot follow the the information, the course in this session. Please review it and watch the videos. Okay. Then, in summary, we finish this session. In summary, we can calculate the outputs, and we can learn how to update the weights. But the next question is that how we continue this processing how many times, and how we can understand that this is good or not. Okay, in next session we will review and we will study about this concept. Okay, then I recommend you review these pages. It is too simple. Don't worry, please don't worry, too simple. And because maybe you don't watch the previous videos, you can't follow this session. The only reason is that. But it is too simple. I then follow the pages and review the pages, 82 pages of Rashid book. If you don't have any questions, we finish this session. Okay, thanks for your participation in this session, and thanks for your attention. Bye, and I see most of names here. Okay, please study the books. Bye to all of you, and good luck, and be successful, and good afternoon. Good afternoon, and have a good time. Bye.